The Fermi Paradox, is it a real possibility, or just a figment of humanity's imagination, a mere urban legend? Is this rumor ultimately a good thing or a bad thing? Tonight, once again, we'll examine whether it's true or not from a Japanese perspective. The universe is 13.8 billion years old. It contains 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. A significant portion of those stars have planets. A significant portion of those planets sit in habitable zones where liquid water, the baseline requirement for life as we understand it, can exist. The math, when you run it, produces a number so large it has no practical meaning to the human brain, and yet that we have been listening to the sky for over 60 years. With radio telescopes, optical arrays, and instruments sensitive enough to detect a signal from the other side of the galaxy, we have scanned hundreds of thousands of stars. We have sent our own signals outward into the dark, and in 60 years of listening, nothing, not a whisper, not a pattern, not a single unambiguous sign that anything, anywhere out there, has ever looked up at its own sky and wondered if someone else was listening. The universe should be full of voices. It is completely silent, and that silence, that specific, total, mathematically impossible silence, is the most terrifying unsolved mystery in all of human history. This is the Fermi Paradox. And once you truly understand it, you will never look at the night sky the same way again. Part 1. Introduction. There is a category of question that changes you permanently once you encounter it. Not because it frightens you in the moment, but because it follows you. It sits in the back of your mind at 2 a.m. It surfaces when you're driving alone and the radio cuts out and there's nothing but static. The Fermi Paradox is that kind of question. It has fascinated physicists, philosophers, astrobiologists, and military intelligence agencies. It has been the subject of hundreds of peer-reviewed papers, dozens of books, and classified government briefings. Carl Sagan spent a significant portion of his life wrestling with it. Stephen Hawking called it one of the most important unsolved problems in science, and warned, repeatedly, that the answer might be one we are not prepared to hear. But here's what makes it different from every other great scientific mystery. Most unsolved problems in science are hard because the answer is complicated. The Fermi Paradox is terrifying because the answer might be simple, and the simple answers are the ones that should keep you awake at night. That we're going to walk through all of them tonight. Every proposed solution, every theory, every implication. By the end of this, you'll understand why some of the smartest people who have ever studied this problem have concluded that the silence of the universe is not a puzzle to be solved, that it's a warning. Part 2. Background. To understand the paradox, you need to understand the man who identified it and the moment it was born. The year was 1950. The location was Los Alamos National Laboratory in New Mexico, the same facility where the atomic bomb had been developed just 5 years earlier. 4 physicists were walking to lunch: Emil Konopinski, Edward Teller, Herbert York, and Enrico Fermi. Enrico Fermi was, by any measure, one of the most brilliant scientific minds of the 20th century. He built the world's first nuclear reactor. He won the Nobel Prize in Physics in 1938. He was the kind of thinker who could perform complex calculations in his head faster than most people could do them on paper. The 4 men were discussing a recent New Yorker cartoon, a lighthearted piece about a wave of UFO sightings and the speculation they'd generated. The conversation was casual, almost joking, and then, over lunch, Fermi went quiet for a moment. And then he asked a question that stopped the table cold. But where is everybody? That was it. 5 words. No elaborate setup. No lengthy preamble. Just a quiet question from a man who had done the math in his head between the sidewalk and the cafeteria and arrived somewhere that made him go still. Where is everybody? His colleagues understood immediately what he meant. If the universe is as vast and as old as the evidence suggests, and if the conditions for life are even remotely common, then intelligent civilizations should not just exist, they should be everywhere. They should have had billions of years to develop, expand, and make themselves known. We should be surrounded by evidence of their existence, and we are not. That lunchtime question became the Fermi Paradox. And in the 70-plus years since, no one has solved it. Part 3. The Drake Equation. The math that started everything before we get to the theories. We need to talk about a formula. Because the Fermi Paradox isn't just a philosophical puzzle. It's a mathematical one. In 1961, astronomer Frank Drake sat down and wrote an equation designed to estimate the number of active, communicating civilizations in our galaxy at any given moment. You've probably seen it referenced without knowing it by name. The Drake equation multiplies together a series of factors: the rate of star formation in the galaxy, the fraction of those stars with planets, the fraction of those planets capable of supporting life, the fraction where life actually emerges, the fraction where that life develops intelligence, the fraction that develops detectable technology, and finally, critically, the average length of time such civilizations remain detectable. Plug in even conservative estimates for each factor, and the equation produces a number in the range of thousands to millions of active civilizations in our galaxy alone. Our galaxy, not the universe. Our galaxy, one of 2 trillion a million civilizations in the Milky Way right now, and we can't find a single one. That gap between what the math predicts and what we actually observe is the paradox. And it is, when you sit with it long enough, genuinely staggering. Part 4. The complete story. 60 years of silence. Let's walk through the history of what we've actually done to find an answer. And what we found instead. 1960. Project Ozma. Frank Drake, the same man who wrote the equation, pointed a radio telescope at 2 nearby sun-like stars, Tau Ceti and Epsilon Eridani, and listened for 150 hours. This was humanity's first deliberate search for extraterrestrial intelligence. He found nothing. 1972 and 1973. Pioneer 10 and 11. NASA launched the first physical messages into interstellar space. Plaques mounted on each spacecraft carried diagrams of a man and a woman, the location of our solar system relative to known pulsars, and basic information about humanity. These probes are still traveling outward. They will drift through interstellar space for millions of years if anyone ever finds them, and no one has confirmed that. They will know we existed. 1974. The Arecibo message, the most powerful radio signal humanity has ever deliberately broadcast, was sent from the Arecibo Observatory in Puerto Rico on November 16, 1974. It was aimed at the globular star cluster M13, approximately 25,000 light-years away. The message contained information about our number system, the chemical basis of DNA, a diagram of the double helix, a figure of a human being, and the location of our solar system. It was transmitted once. If a civilization at M13 receives it and responds immediately, their reply will reach us in approximately 50,000 years. We are still waiting. 1977. The wow signal. And here is where the story takes a turn that has never been fully resolved. On August 15, 1977, astronomer Jerry Ammon was reviewing data from the Big Ear radio telescope at Ohio State University. He was scanning for anomalous signals from deep space, the kind of search that was, by that point, routine and mostly unremarkable. And then he found something. A signal lasting exactly 72 seconds. Narrowband, appearing to originate from the direction of the Sagittarius constellation, exhibiting characteristics that, according to the researchers who reviewed it, were precisely what a signal from an extraterrestrial intelligence would be expected to look like. If it were it has never been detected again. No natural astrophysical phenomenon has been identified that could have produced it. No1 is claimed to have sent it. It appeared once from deep space in precisely the frequency range that scientists had theorized an intentional extraterrestrial signal would use. And then it was gone. 1992 to present. SETI and the Long Silence NASA's high-resolution microwave survey began in 1992. It was canceled by Congress in 1993 after 1 year of funding. A senator famously mocked it on the floor of the Senate. It was revived through private funding as the SETI Institute, which has continued listening to this day. Decades of observation. Millions of star systems scanned. Signals of interest detected, investigated, and either explained or filed unresolved. And through all of it, nothing that holds up. Nothing that can be confirmed. Nothing that answers the question Fermi asked at that lunch table. Where is everybody? Part 5. The theories. This is the part that changes how you see things. Because there are proposed solutions to the Fermi Paradox. Many of them. And none of them are particularly comforting. Theory 1. The rare earth hypothesis. The first and most conservative explanation. We are alone because the conditions that produced us are extraordinarily, almost impossibly rare. Earth is not a typical planet. It orbits a stable, middle-aged star at precisely the right distance for liquid water. It has a large moon that stabilizes its axial tilt, preventing climate catastrophe. It has a Jupiter-sized gas giant in an outer orbit that acts as a gravitational shield, deflecting asteroid bombardment. It has plate tectonics that regulate its carbon cycle. It has a magnetic field that deflects solar radiation. Remove any one of these factors, the rare earth argument goes, and complex life doesn't develop. Remove several of them, as is common for most planets, and the silence of the universe is simply the silence of a cosmos where the specific recipe for intelligent life has only ever been achieved once. That we are not one of many. We are an accident, a statistical miracle, alone by default. This is the most comforting solution to the Fermi Paradox. It is also the most lonely. Theory 2. The Great Filter. Now, we move into darker territory. The Great Filter theory, proposed by economist Robin Hanson in 1998, argues that somewhere along the path from simple chemistry to spacefaring civilization, there exists a barrier, a filter, that almost no species survives. The critical question, and this is where it gets genuinely disturbing, is, where is the filter? If the filter is behind us, if the nearly impossible step was something early in our history, like the emergence of the first self-replicating molecules or the jump from single-celled to multi-celled life, then we may be safe. We've already passed through it. The universe is silent because most civilizations never got as far as we have. But if the filter is ahead of us, if what kills civilizations is something they always do to themselves once they reach a certain level of technological development, then the silence of the universe isn't an absence, that it's a graveyard. And we are walking toward the same wall that every civilization before us has already hit. Theory 3. The dark forest. This theory was popularized by Chinese science fiction author Liu Cixin in his novel The Dark Forest, and it is, in the opinion of many who study this problem, the most psychologically sophisticated of all the proposed solutions. The argument goes like this. Every civilization in the universe faces the same fundamental problem. Survival requires resources, and resources are finite. A sufficiently advanced civilization has no way to verify whether another civilization is friendly, and no way to guarantee that a currently friendly civilization won't become hostile as its needs expand. The stakes of being wrong are existential. Given these conditions, the rational strategy for any civilization that becomes aware of another is not to make contact. It is not to respond. It is to eliminate the threat before the threat can develop the capability to eliminate you. The universe, in this model, is a dark forest. Every civilization is a hunter, moving silently between the trees, careful not to make a sound. Because anything that makes a sound, anything that reveals its location, gets found by something that was already hunting. In this model, our decades of radio broadcasts, our Arecibo message, our pioneer plaques, we have been shouting our location into a forest full of predators, and we are waiting to see what hurt us. Stephen Hawking, in his final years, endorsed a version of this concern explicitly. He argued that attempting to contact extraterrestrial civilizations was, and I'm paraphrasing here, one of the most dangerous things humanity could do. His reasoning was straightforward. We have no basis for assuming that a civilization capable of reaching us would treat us as equals rather than as resources. He compared it to the moment the indigenous peoples of the Americas first made contact with European explorers. That comparison should land with some weight. Theory 4. The simulation hypothesis here is where we step off the map of conventional scientific discourse and into something that a surprising number of serious thinkers have endorsed. What if the silence exists because there is nothing out there to find? Not because life is rare, not because civilizations destroy themselves, but because the universe we are observing is not the fundamental reality. It is a constructed environment, a simulation, and the absence of alien civilizations is simply a design parameter. Oxford philosopher Nick Bostrom formalized this as the simulation argument in 2003. The basic logic runs as follows. If it is possible to create convincing simulations of conscious beings, and if civilizations tend to create many such simulations, then the number of simulated minds will vastly outnumber the number of real minds. Therefore, statistically, any given mind, including yours, including mine, is more likely to be simulated than real, and a simulated universe can be as detailed or as sparse as its creators choose to make it. The silence, in this model, is not a mystery to be solved. It's a feature. We're the only ones here because whoever built this didn't populate it with anyone else. Elon Musk has publicly stated he believes the probability that we are living in base reality is 1 in billions. Neil deGrasse Tyson put the odds at 50-50. These are not fringe thinkers, and if they're right, if this is a simulation, then the Fermi Paradox dissolves. There's no one out there because there's no out there in the way we think there is, which raises a question that is, in its own way, more terrifying than any of the others. Why are we here at all? Theory 5. They're already here now. This is the one. This is the theory that the mainstream scientific community officially does not endorse, and that several people with verifiable, documented access to classified government information have, in recent years, stated is the correct one. What if the reason we haven't detected extraterrestrial intelligence through radio telescopes and space probes is not because it doesn't exist, but because it is operating at a level or through a mechanism that our instruments were never going to detect? What if they arrived long before we started listening? What if they are here right now? The UAP, Unidentified Aerial Phenomena, hearings before the United States Congress in 2023 produced testimony that, in any other context, would have generated headlines for months. David Grush, a decorated former intelligence official with active security clearances, testified under oath that the United States government has been in possession of and has actively concealed from Congress and the public physical materials and biological remains of non-human origin for decades. He named specific programs. He named specific locations. He stated that individuals had been threatened and in some cases, harmed to maintain the secrecy of this information. He has not been charged with perjury. He has not been charged with making false official statements. Multiple other witnesses with documented military and intelligence backgrounds provided corroborating testimony. And then, within weeks, the news cycle moved on. But here is what that testimony, if even partially accurate, means for the Fermi Paradox. The silence wasn't real. We were never actually alone. And the question was never where is everybody. The question was always who decided we shouldn't know they were here. Part 6. Deep analysis. Let's apply some pressure to these theories, because several of them have problems that don't get discussed enough. The rare Earth hypothesis is plausible, but it becomes less plausible every time we discover a new exoplanet with Earth-like characteristics, and we have now confirmed over 5,000 of them. The James Webb Space Telescope has detected atmospheric signatures consistent with biological processes on at least 2 candidates. The universe keeps offering up more Earths. The hypothesis keeps requiring more reasons to dismiss them. The Great Filter theory is internally coherent, but it forces us into an uncomfortable choice. If we find evidence of simple fossilized life on Mars, bacteria, microbial mats, anything, that is, counterintuitively, catastrophic news. It means the early evolutionary steps that seemed impossibly rare were actually common, which means the filter is probably not behind us, which means it's ahead, which means the silence of the universe is the sound of everyone who came before us walking into the same wall. This is why some astrobiologists have stated publicly that they are actively hoping the Mars missions find nothing. A barren Mars is a hopeful Mars. A Mars with ancient microbial fossils means the Great Filter is waiting for us. The dark forest theory is elegant, but it contains a paradox of its own. If all civilizations are hiding, then there should be no detectable signatures of anything out there. No megastructures, no Dyson spheres, no evidence of large-scale engineering. But in 2015, the star KIC 846-2852, Tabby's star, displayed light dimming patterns so unusual, so irregular, so unlike anything produced by known natural phenomena, that the first published explanation suggested large-scale artificial structures in orbit. That explanation was later complicated by additional data suggesting possible dust clouds. But possible dust clouds is doing a lot of work. The light curves of Tabby's star have never been fully explained by any natural model. And if even one of the proposed explanations involving artificial structures is correct, even as a partial contributor to what we're observing, then someone is out there. And they're not hiding well enough. And finally, the testimonies. The congressional UAP hearings were not the first. They were not isolated. They were part of a pattern of disclosure that has been accelerating since 2017, when the New York Times first reported on the existence of the Advanced Aerospace Threat Identification Program, a classified Pentagon program that had been studying UAP for years without public knowledge. The New York Times. Not a fringe outlet. Not an anonymous forum post. Program existence confirmed. Footage declassified. Witness testimony on record under oath. The question is no longer whether the government has been studying this. The documentation confirms they have. The question that has never been adequately answered, is what they found. Part 7. Modern implications. The Fermi Paradox has moved out of the realm of theoretical physics and into the arena of active policy in a way that most people haven't registered yet. The U.S. government has established the All-Domain Anomaly Resolution Office, AARO, as a permanent body within the Department of Defense, specifically tasked with investigating UAP. This is not a temporary committee. It is a permanent office with a budget, with staff, and with a congressional mandate to report its findings. The United Nations has had preliminary discussions about establishing protocols for first contact. What to do legally and diplomatically if contact with non-human intelligence is confirmed. Those discussions exist because someone in the relevant offices believes it is necessary to have them. The search for technosignatures, evidence of technology rather than biology, has received renewed funding and attention at NASA. The James Webb Space Telescope has atmospheric analysis capabilities that its predecessors did not. We are, right now, in the most capable period in human history for answering the question Fermi asked, which means we are also in the period when an answer, any answer, becomes most likely. And here is the thing that the researchers who take this seriously want people to understand. Every proposed solution to the Fermi Paradox has implications. The rare earth solution means we are alone, the last light in a dead universe, with no one to call if we extinguish ourselves. The great filter solution means a civilizational catastrophe is statistically likely in our future, and the clock may already be running. The dark forest solution means contact, if it happens, carries existential risk by default. The simulation solution means the nature of reality itself is not what we think it is. And the "they're already here" solution means there has been a concealment operation running at the highest levels of government, and possibly others, for longer than most of us have been alive. None of these answers are comfortable. Every single one of them changes something fundamental about what it means to be human, alive. In this moment, the silence of the universe is not a background condition to be accepted and moved past. It is the loudest, strangest, most consequential thing about the world we live in, and we are, right now, in the process of forcing it to speak. Part 8. The final question. Fermi asked his question over lunch in 1950. He asked it simply, almost casually, and then he died 4 years later without an answer. The question is still open. We've sent signals into the dark. We've built machines to listen. We've launched spacecraft carrying diagrams of ourselves into interstellar space, like messages in bottles thrown into an ocean with no visible shore. We've heard one thing. One signal, 72 seconds long, in 1977, that has never been explained and never repeated. And we've heard nothing else. Maybe the universe is simply empty. Maybe we are the miracle. Maybe the story of life on this planet is the only story the cosmos ever told. Maybe something is out there, watching the same dark forest logic play out, deciding whether to stay hidden. Maybe the filter is behind us. Maybe it's ahead. Maybe the governments of this world know something that the rest of us have never been told. And the conversation happening right now in classified briefings is the most important conversation in human history, and we are not in the room. Or maybe, and this is the possibility that stays with me most, maybe the answer to the Fermi Paradox is one we have already received, and we simply don't have the framework yet to recognize what it means. The universe is 13.8 billion years old. We have been listening for 60 years. Whatever is out there has had a 13 billion year head start. So here is what I want to leave you with tonight. Of all the proposed solutions to the Fermi Paradox, the empty universe, the great filter, the dark forest, the simulation, the ones already here, which one do you think is true? And which one do you hope isn't? Leave your answer in the comments. This question deserves more voices than it has. This has been ULW Radio. We'll see you in the next legend.